This revision tutorial will be based on momentum. For rigid bodies, we are concerned with both translational and rotational momentum. The equation that we have used previously, F equals ma, provides only enough equations to solve for translational moments. Furthermore, this is designed for particles. When considering the linear momentum of a body, or a particle with several forces acting on it, we must change F equals ma into the resultant force, F, and the acceleration of the centre of mass, A. The over bar on the A denotes that this refers to the centre of mass. What about angular momentum? In a planar setting, we can define angular momentum as a product of the mass moment of inertia and the angular acceleration. The over bar here denotes the centre of mass, that it is based around the centre of mass. This is assuming taking around angular momentum around the centre of gravity G. If we had to take it about a fixed point O that has zero velocity, which must have zero velocity, the sum of the moments at O is equal to the mass moment of inertia at O multiplied by the angular velocity of each point. These are fairly simple uses of this. However, we can also choose an arbitrary point P to sum our moments around, and this is often more convenient to do so. At a point P, the sum of our moments is equal to the mass moment of inertia of the centre of mass multiplied by the angular acceleration in addition to the R, G relative to P, cross product, the mass multiplied by A, centre of gravity. In the planar case, this reduces to the sum of the moments of P is the mass moment of inertia multiplied by angular acceleration, adding the mass multiplied by the acceleration at the centre multiplied by distance between P and G, which will be perpendicular to the direction of A. Now, some explaining of these formula. We can always write the balance of angular momentum at the centre of mass G. If there's a fixed point, we may write it as the sum of moments at O. And furthermore, we may also write it as the sum of moments of P if this is more convenient. So, how do we use these? How do we use these formula to find the total motion? The first most important thing to do is to draw a free body diagram. Next, we choose a point to sum the moments around and calculate the mass moment of inertia. It is important to choose a point to sum the moments around that will be most efficient in solving your equation. Next, we must find the resultant force and moments. Using our balance of linear momentum to find the translation of the centre of mass. Then, we use the balance of angular momentum to find the rotation. Next, and finally, we use relative motion to combine translation and rotation together to give us our final answer. Thank you, I hope you got something out.